Hello and welcome dear learners to the Healthcare Quality Management course on Infection Control and Patient Safety, Module 1, Foundation of Healthcare Quality and Infection Control. In the lecture 8, Quality Tools for Continuous Improvement, Part B, we will be seeing the quality control tools. We'll be studying over here the 7 important quality control tools. What are those? The tools are cause and effect diagram, which is called even as Ishikawa diagram. The check sheet, control chart, histogram, Pareto chart, scatter diagram, and stratification. These all are very important for the quality tools to be seen as being implemented for the continuous improvement in quality. So, in the introduction, I would like to emphasize for the 7 basic quality tools, also called as the first 7 or the classic 7, and are simple yet very powerful methods used to solve problems and improve quality. These 7 tools are easy to use. You don't have to confuse, you don't have to bother. And are these tools considered essential? They are extremely essential for anyone working the quality improvement. You cannot compromise without working this. So the 7 basic quality tools were first introduced by Karo Ishikawa and well known in the book Guide to Quality Controls. Later, the other authors like Nancy Tage also discussed them in the books The Quality Toolbox. When used properly, each of these tools can make a big difference in improving quality. Their usefulness increases every more when they are applied together. So the application of all these tools are very important actually when you have to see the best results. The cause and effect diagram, also called as fishbone diagram or Ishikawa diagram, which is a very popular tool. This tool is also known as a fishbone or Ishikawa diagram. This tool helps find out why a problem happens. It was popularized by the renowned Japanese quality expert Kara Ishikawa. And so the name is also known as Ishikawa diagram. You might have heard that it is also known as fishbone diagram. So there is also a fish and the bones to be discussed. The cause and effect diagram is a well-known tool that shows the link between what happens as a causes and the results that flow in the effects. It is based on a simple idea that every effect has a cause. The effect is just the visible result of that cause. So you can find I have emphasized that effect is just the visible result of the cause. So you have to work on the cause. If the cause is removed, the effect will also disappear with it. You can see this fishbone diagram over here and you can find the head of the fish as a problem, the machine where you can say the mechanistic thing, the measurements, the methods, the mother nature, materials and manpower. So these are the main causes and to this there might be small bones for the fish to be seen as sub-causes. So every of the problem can be used and mapped into this fishbone diagram. In continuation, after the fishbone diagram, we would be trying to emphasize more on the check sheet. How check sheet is being seen as a simple form used to collect and organize the data. So every time you have to emphasize on getting the data clearly, organizing the data clearly in check sheet. Check sheet has different categories and each time something happens and a check mark is added in the right category. So there is always a point of emphasizing on right category. This happens to count how often each event or issue occurs. It is useful for keeping track of how a process or activity performs over time. So check sheet has its very valuableness into the quality tools. Examples, a hospital wanted to find out why outpatient consultations were getting delayed during the week. And what is the reason actually these things are going on? The staff made a list of common reasons. They have in their mind that what is the reasons actually we need to enlist. And so are there such as a reason coming as a doctor's arriving late, missing patient papers, equipment not being ready, and so on. So each time a delay happened, they marked it as an on the check sheet under the correct reason and the date. They enlisted all the possibilities actually why the reason happened, what is the cause and the date. At the end of the week, they checked in the entire check sheet and this showed that most delays were caused by incomplete patient documents. So can you see, when we list all these things, you will identify few of the common things. In this particular example, this helped the problem to be fixed by the hospital and the check sheet was found to be very useful. This can be seen as a check sheet where you can find a daily ward round patient check. And you may see the observations, the task actually, patient awake, call button, fluid operate. So these are the things, and you can see the total checks in number, you can count in 50, 100 and so on. You can give specific notes if you really require that how it is. You can put it in the form of a shift also, first shift, second shift, third shift, in that way. You can mention about a particular person like a nurse or a doctor or any employee. Then in continuation comes the third quality tool that is called as control chart. This is also known as Sheward chart. Okay, don't get confused with this. The name can be even a Sheward chart. So the control chart is a simple tool used to see whether a process is working properly or not. So this is particularly focusing on the process part compared to the previous two tools. This tool helps us to check if the process stays within certain limits and alerts when there is a problem. So it is very important in a healthcare system which is a very unprecedented to receive so much of casualties, so much of difficulties that the patient may face even during the hospitalization. The information is collected over time and plotted on a chart to observe any changes in the performance. So you can track down the problems. You can even map up actually the different incidences the patient is going on from admission to discharge. What does a chart gives you? A chart includes a central line that shows a normal or target value. Second, it shows upper and lower lines that show the acceptable range of performance that, oh, it can be cumulated and you can see the performance is acceptable. So if the results go beyond these limits, it means something unusual has happened and you need to give an alert. There can be a notification which can be raised after this, and this needs to be investigated or corrected. I'm not saying that it should be blamed, it should be pointed, people should be removed. It is to be investigated what is the reason of this and need to be corrected. That's the purpose of using this tool. So control chart can be applied to any kind of process in the healthcare. In hospitals, they are often used to monitor things like fever trends, blood pressure, infection levels, or other health indicators. Too many health indicators, control chart can be seen, or the Sheward chart can be seen as the best possible way to actually to deal this. There's an example I would like to quote over here. In a hospital, the hospital recorded average waiting time for a patient in the outpatient ward for 1 year, entire 1 year. And you know how the OPDs are full, and you may find these problems everywhere, every hospitals in our country. Each week's average was plotted on a control chart. For several months, the waiting time stayed with normal range. But in the month of March and April, it crossed the upper limit compared to the expected performance. So after checking this, the team found that the cause was staff shortage. And additionally, there was a problem of maintenance of the equipment. So two things were there. What is that? Staff shortage and maintenance of equipment. So the team come to know these issues. Once these issues were resolved, the waiting time came back within the normal limits. This is the process stability analysis. You can see it and you can do it. So the upper control limit, the lower control limit, and the central line where you are expected every time the process should go on. If you find it is going lower, it is going upper, you can improve it. You can improve it by correcting it. You can improve it by understanding it, identifying the cause. Now comes fourth in line is histogram. Histogram is a chart that shows how data is spread out. Here you require a lot of data. Histogram helps to see patterns that may not be clear when looking at numbers in table. A histogram looks like a bar chart and shows how frequently data falls into different groups or categories. It gives us a clear picture of how results or responses are distributed. Histograms are helpful in spotting trends in data. The data which can be taken by the patient's information. So, the histogram can show whether the data is evenly spread, that is called as normal, or leaning more to one side, that is skewed, where you need to worry about improving this. How to make a histogram then? First, collect the data and find the smallest and largest value. Then divide the range into 5 to 10 groups. Means you have to subdivide it. Count how many times the data falls in each groups and draw bars to show these counts. So you can easily guess where it is normal and where it is skewed. This is an example of a histogram to be seen in a hospital. A hospital wanted to study the recovery time of patient after a surgery. How much time it takes, because you have to worry about the infection, even about the condition of the patient, about the comorbidity. So the recovery days of all patients were recorded and grounded in interval such as 0 to 5, 6 to 10 and so on. The extended length of stay can also be taken over here. You can understand the post-surgical complications. You can even understand the infection, like you may say post-surgical. So many things you can get in the length of the stay. A histogram was then being seen to illustrate the number of patients who recovered within each time range and someone who is excluding. Distribution of patient ages. This is also one and good example where you can find with respect to age and number of patients. This is the good explanation of this. Then comes the Pareto chart. A Pareto chart is a type of bar graph used to find and focus on the main problems that affect quality or the process result. So this bar represent the different causes and are arranged from the biggest to the smallest. This helps to clearly see which problems have the most impact. So according to the Pareto principle, around 80% of the issues comes from about 20% of the main cause. So main cause gives reason for 80% of the issues. So using a Pareto chart which helps identify the key causes, they should be addressed first and then later the next by improving the quality of performance. In a Pareto analysis, data about different problems is collected and shown in a table with their frequency, percentage and total percentage. Then a bar graph is made based on the information which helps you to give the entire picture of this. This is an example of an Pareto chart in a hospital. A hospital studied the common types of medication errors made by nurses for 1 month. So this is sort of a small project that you can do it in a quality for your hospital also. After collecting the entire data of this problem, a Pareto chart was drawn. The chart showed that the two main reasons came. What was the reason? That was giving wrong dose and giving medicine at a wrong time, and where possibility of the response was that most of the problems, and you may find that this can be seen in the chart as well. What did the hospital did? The hospital team then focused on finding out why these two errors of wrong dose and giving medicine at wrong time. So time was a problem, dose was a problem. So this was happening and worked to prevent them in future. The hospital has to work, importantly working on the medication error like such issues. So this can be seen an example of a Pareto chart. And this is where you can find how the frequency, the percentage and all those works on. Next in line of the quality tool is the scatter diagram. The scatter diagram is a chart that helps to show how two variables are related. So there is a relationship which is being shown over here. In plot data points with one variable placed on horizontal axis and the other on the vertical axis. So you may find horizontal axis, vertical axis. So if these two variables are related, the points will form a pattern close to a line or a curve. The stronger the connection, the nearer the points they have to that line. So this tool helps to check whether there is a meaningful link between these two factors in a process. So again, this is working more on the process part. So if a relationship is found, the factor causing the change, it should be worked on to get the desired outcome. So if there is no link in this, then possible factors should be reviewed to see the reason behind the result. So there is a possibility that there can be no link also, and sometimes or every time you may even find there is a relationship which is found and you can work on that. This is an example of this of scatter diagram. In the scatter diagram below, the relationship between two major factors, the length and the weight of steel bars with same diameter is being shown. The horizontal x represents the length and the vertical y represents the weight. From the pattern of the plotted points, it can be seen that there is no clear link between the bar's length and the weight. So this shows that the cross section of the bar is not consistent, likely because of weak process control, which is very much understood with the help of the scatter diagram. You can see over here positive linear, negative and linear, non-linear curve and no relationship, which will explain you how the scatter diagram helps. Then comes the stratification. You can call it as flow chart or run chart. Stratification is a way to find out where variations in data common come from. It involves dividing or grouping collected data based on different factors. What are those factors? The factors can be such as people, machine, time and locations. By spreading this data this way, it becomes easier to see which factor is causing changes or the problems in the processes. So this is again emphasizing as a quality tool on the processes, the problems in the processes. So for instances, if the same task is performed by different staff member at different places or in departments, the data can be grouped by person or by department. So you can find the stratification being seen at different places also. Is it to see the performance of the employees? Yes, it can be seen. Is it for the people's performance at different places of same type of people? Yes, it is. Is it being seen to compare the performance of the people? Yes, it is. So it is very important that a flow chart can be used as a very identified tool actually for the quality improvement. The stratification helps in identifying which area is showing variation and which area needs to go for improvement. So this is where you find the stratification or a flow chart which helps you. Here you can see of mobile users, tablet users and desktop users, and even overall issues of frequency happening which might be seen, and where you can see and concentrate on the leakages. You can work on the volume actually where the leakages are more being seen over here. The example coming for this particular scatter diagram is more like the hospital noticed that the time being taken for a discharge varied a lot actually. And to understand why the team has this problem, they collected the data from different hospital departments such as surgery, gynec, medicine, pediatrics and so on. At first, all the data was analyzed together, but no clear reason was coming out as a delay. And it was to an astonishment actually how this stratified, or you can say the flow, when the team separated or stratified the entire data by department to department, they become very clear that the surgery department took longer discharge times. Not as usual as surgery takes. It can be a comparison that the surgery department can be done with the pediatrics or even by emergency and so other departments. So this helped the hospital and the hospital team to focus on the findings and fixing the issue in this specific department. And this made a great benefit to the hospital. So in summary to these chapters actually, where we focused on the 7 basic quality tools, which are very easy to understand and are very simple but very effective methods to understand, analyze and improve the process. We can see the 7 basic tools can be used combiningly also, and the best results are being seen when you are using it combiningly. Together these tools helps identify the root causes of the problem, organize the data, monitor the process performance and spot patterns, focus on key issues that affect quality. So, do you find that these tools are used friendly? Yes, they are user friendly and forms the basis of quality management. You can find the entire benefit of getting the basics of this will help you to get the culture of quality. When used of these tools are done correctly, these tools reduce errors, improve consistency and support effective decision making. They are very essential for maintaining and improving quality in any organization. You can find in terms of diagnostics, you can find in terms of hospital, you can terms in terms of any department where you want to even focus singly on a problem. Especially in healthcare and service sector, this has been randomly used actually and has been benefited a lot with respect to the problems that arise, the key issues and the patterns and even the performances. So if you try to go in detail of understanding this, this can be more benefiting. So thank you for attending this and we will continue with the next course of discussion in the coming chapters. Thank you very much.